Hello friends, welcome to this channel. Here we are going to look at this problem, maximum value of an ordered triplet. So this is the first of such problems. So it's marked as easy by leetcode, and indeed the logic is very straightforward. So here I'm going to use prefix or suffix maximum or min, right? In other words, it's not prefix. This is to be distinguished with prefix or suffix sum, because no matter maximum or min, so they're just the functions, right? So this is sort of dp, but too straightforward. Therefore, I'm not going to term it as dp here. So here, this is the problem statement. We want to find the maximum value over all triplets of indices I, j, k. I is less than j is less than k, right? So this is the expression, right? The value of a triplet. So in other words, the first one minus the middle one, then the sum, the difference is multiplied by the last one, right? So here, by the assumption, right, the numbers are positive. So this greatly simplifies the problem, right? So actually, we can fix the g. So here, the g, we should consider j is in between. So j is in between, let's see, 1 and n minus so let's see, j should be like this, greater than 0, or right like this. J is greater than or equal to 1, less than or equal to n minus 2, right? So that's the range for j, because we need to have I and k, right? So then for this problem, in order to maximize this one, there are two ways, two possibilities. First is that we for each j fixed, right? So this nums j will be fixed. So we want to find the largest number to the left. That is, we can serve it as nums I. And then also we need to find the maximum element to the right, right? So this is what we want to find. So at every element in A, because here as I write, so as every element is positive, then the return also should be greater than or equal to 0. Then the problem is very greatly simplified, right? So if you have all those things, right, like AI is less than AJ, then the final return shall be 0. This can happen, for example, if you have a array which is strictly increasing, right? So here is the comment. Actually, you can also come back to this afterwards. If we do not assume the nums I is positive, you need to consider both the left side maximum and minimum, and the right side maximum and minimum, and then you compare the 4 different products, right? With that said, let's quickly look at the coding. The coding should be rather straightforward. I changed the nums to be A just for convenience of writing, right? So I'm going to have a max before, so it's 0 times n. This is in the size, and the max after, right? So also be 0 times n. First, I'm going to do some preset, right? For example, max before 0, because we know that we need to consider j from 1, right? So then we can make this one to be a0. So similarly, after, right? So here I will write n minus 1. So because we need to consider j from n minus 2, I can make this one, say, a n minus 1, right? So then what we want to do, so I'm going to write 2 for loops just to demonstrate the idea. First, for j in range 1 to n, right? So actually, n minus 1 will be enough, but let's write like this. So what we want to do, so for current j, we want to find the max to the left. So what we want to do, what we can write is max before j. It should be the max of max before at j minus 1. And then we take maximum with respect to a j minus 1, right? So this is the one. Another one is that we can do this from n minus 2 to 0, right? Then we get max after j, right? So this will be the max of the max after at j plus 1, and then compare with a and j plus 1. So you need to pay attention to the indexing, right, and our convention. So with this done, actually we can get the final return. So because if all things are negative, we are going to return 0. So here I'm going to set result to be 0 and then iterate. So for j in range 1 up to n-2, so we write n-1 here, right? So the result will be this, the max of its previous state and then the current state. The current state we want to find is the max before this j, right? Then minus aj. So this is the difference part, and then times the max after, right, after this j. So then we can return the result. So this will give us the maximum triplet sum. So let me run it. It passes the 3 cases. So if you like, you can also print out those 2 lists, right? So now let's submit for the generic case. Yeah, it passes all the generic cases. So with that said, I guess that's basically about it for the problem. So as I mentioned here, I used ON space. For time, it will be also ON. And then the code can be readily changed if you want to achieve O1 space. This is also a good practice. So with that said, I guess that's it for the current problem. Thank you for watching.